AP Statistics. In this video, we're going to go through some more Unit 3 examples, so I hope everyone is ready for some fun. Okay, so example 6 right here, I've got a student interested in joining the band, and he's going to go to Texas A&M in the fall. Life is worth living, blah, blah, blah. So basically, we're looking at different sampling techniques used in each scenario. So let's just go through these. So the first one is all Texas A&M band members are listed in alphabetical order and numbered. I choose a random number 1 through 5. That will be my starting point. So whichever that student is becomes my first in my sample, and then I systematically select every 5th person on the list until I get to the end. That's why we call it systematic, because we randomly start somewhere and then we systematically go through a list. Yay. Okay, part B, I separate the band members into 4 grade level lists, and I've got each grade alphabetized and numbered. I use a random generator to select 10 students from each grade level. Okay, this is called stratified because I'm separating all of the band members based on a characteristic that they all have, or in each group they all have in common, because I think it might affect how they respond to my survey. So might grade level affect how you respond? Absolutely, because a sophomore and a junior are going to have their act together way better than a freshman, in theory. So I would separate why can't I talk? So I would have my freshmen, I'd have my sophomores, I'd have my juniors, I'd have my seniors, and then I would take a random sample from each of my strata. That's how I would do that. Okay, part C, I put section names in a hat and I draw 3 of them. I survey all the students in each chosen section. Well, if you know anything about band, you know that depending on what you're playing, you're usually together. So this would be a cluster sample because in theory, all of the people in a particular section are alike based on where they are, like a location. They're near each other. So that's what a cluster is. And then all members are listed in alphabetical order and numbered. I use a random number generator and get 40 students. That's just a simple random sample because it's simple. Okay. The last one, I stand outside the practice room surveying students who practice between 8 and 10. That's because that's going to be convenient for me. This actually is, remember, bad sampling. Bad sampling. We don't like it. All right. Number 7, we have a librarian here, and we want to know the average number of pages in all the books in the library. If we have 20,000 books, which are arranged by type. I know many of you don't go to libraries anymore, but that's how they're arranged. And then we've got shelves that hold 50 books each, and we want to select a random sample of 500 books. Because looking at how many pages are in 20,000 different books, that's going to be overwhelming. We don't want to do that. So we want to take a sample out of our population of 20,000 books, and we want to take a sample of 500 books. So on part A, explaining how to select a stratified random sample of 500 books, justify your choice of strata. Why might the librarian want to choose a stratified random sample? Okay, so a stratified means that I am going to separate the books by type. That is correct, not location, but by type. Actually, in a library, that would be location, but that's beside the point. So stratified means that I'm going to look at all the mysteries and all the biographies and all the blah, 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 blah. So if I decide to take a simple random sample of each type of book, all right, that might give me a good idea of an average page number of the books. Because remember, certain books tend to be longer than others, like poetry books are usually pretty small, whereas long history books are pretty big, right? Things like that. All right, so when you're taking your sample, you're going to take an appropriately sized simple random sample. What does that mean? Well, that means that I'm not going to want to take the same sample size of each of my strata necessarily, because there are going to be more of some kind of books than others. So I would want to take an appropriately sized sample based on the overall percentage of all the books that I have within that particular genre. So that's what I've explained right here. All right. Okay. So if we are looking at the same scenario, how might we select a cluster sample of 500 books? Well, cluster, if I'm looking at clusters, that usually has to do with proximity. So this might be a good way to sample based on where the books are located, just so I won't be running all over the library. So what might that look like? Well, since the books are separated 50 books in a shelf, if I take a selection of random 10 shelves and count all the books on them, or all the pages in all those books, that might be a pretty good way to take my random sample. So those are just a couple of ideas there. All right, so moving on through our examples, I know you're all excited. So read my lovely example about Boy Scout Peterloo. So he is going to take a sample of 30 homes, and he's going to visit them dressed in his uniform, his Boy Scout uniform, and he's going to ask people if they support the Boy Scouts. What is wrong with this survey? Well, kids, let me tell you something. If this kid shows up to all these people's houses in his Boy Scout uniform and asks their opinion about the Boy Scouts, what are they going to do? They're not going to go, I hate them. Hello? So automatically, just by the way he is presenting the information based on how he's dressed, that is going to cause response bias. Response bias occurs when we have a situation in which something in the wording of the question or in who is presenting it, in this case, who's presenting it, is going to affect the response. That's why it's called response bias. Okay, so because Peter's wearing his uniform, that might sway people one way or the other, which means he's going to overestimate the true proportion of his neighbors who support the Boy Scouts. All right, in example 9, we are looking at what kinds of bias can occur and what those situations might look like. So make sure you pause the video and read the example here. So in part A, our intern who drafts the survey has put his favorite furniture choice first and made the picture bigger. Is that going to influence possibly your opinion? Yes. By the way the information is presented to you. So that's response bias. Okay, we send out an email to all employees and ask them to respond if they wish. Well, what's going to happen? You're going to have voluntary response bias because not everybody, only the people who feel strongly one way or the other are going to respond. And in the next one, since Google's a big company, they decide to send the survey to only the executives. What are you doing? You're leaving out everyone else, and you're doing it on purpose. So this is going to be an undercoverage situation, all right? People can't respond who aren't executives because you didn't send them the survey. All right, part D, the survey goes out to employees the same week. Most of them had a deadline for a big project. Only a handful of employees responded. So this would be a non-response situation. Often students get a non-response situation mixed up with a voluntary response situation. So I want you to recognize the difference. The difference is in the expectation. All right. So if I send out an email and ask them to respond if they wish, there is not an expectation that you're going to respond. I'm just telling you if you want to. With part D, we send out a survey to the employees indicating that we're sending it to them. We're not just saying, hey, here's an email, here's a survey, respond to it if you want. I am sending this with the indication that I want them to respond to it. So for this one, if you wish, I'm going to get voluntary response bias. If people don't respond and I want them to, that's a non-response. Okay. Here, if I'm just saying if they wish, I don't care if they respond, but here I care if they respond and they're not responding. So hopefully that helps out.